Right, now I'm going to try and show you my latest little thing with my RadxaX4 and a camera and a bit of LabVIEW and vision and all sorts of things. So I've moved it ahead a bit, or me and John have. I'm also trying out Camtasia because I got fed up with OBS, so we'll see how that goes. So if we look at our hardware setup here, got my Radxa here, and then we got the camera here. So it's a microscope camera, and underneath it is a little measurement thing that comes with it, which is quite nice for sort of testing bits and bobs, just to see how it's going. So let us switch the Radxa on. I'll find the button. There. Right, he's on. Turn him on, and then we'll move over to the capture card. If I can move over to the capture card. Come on. Let's just power up the Radxa then, and then we'll go and do some stuff. I'll probably show you it powering up, just to show you how quick it powers up. It's very nice. I do like my little RadxaX4. It's a really good bit of kit. Okay, so I've moved over to Ubuntu Cinnamon because I think it seems like the best one that I've been using so far. It just seems to be a little bit more sort of documentation with instrumentation and that kind of thing. Okay, so as you can see, we've been playing with John Medland's tools, and I wanted to get to a point where I captured an image from the capture card or from the camera, and then I did something with that image. Now, I'm not doing something with OpenCV with the image. What I want to do is actually break it out, look at the numbers, and explain what we're seeing. I just thought that would be kind of more applicable. But first of all, first things first, let's go see if we can find the camera. Let's calibrate camera. Why did I do that one? Capture examples, one I want. So it's enumerated the sources and it's found the camera. Oh dear. It's worrying about my Wi-Fi, I think. So if we start there, you can see here now that is on and showing a line. If I turn the light on, you see we flood some light onto it. Doing something. If I move it around, you'll see also it's moving. It's going at a fair old nick, really. Quite nice. But so yeah, we got our image. It looks quite nice. So what I'm going to try and do is just show you how you can sort of measure the thickness and see the thickness of a line, for example, just as an image. So it's a very simple manipulation of the data. Very the most basic probably thing that you could do. So let's open that up. We'll open up our example 2. Okay, so what we have here is same program, apart from I've taken the sort of fancy stuff out, and now because you don't want to be, the Radxa has limited capabilities, so we have to be a bit mindful of that. So originally I did sort of see how it went with a intensity graph and all various different things, but we can see the picture, take a picture, do something with the picture, and that's saves a bit of resources. I'll show that we've got the resource here, and in this case what you have is it comes back as a color image, which is a RGB image. So it's U32 pixels and feel free to correct me if I'm wrong, but the three of them are the red, green and blue, with a bright amount of redness, greenness and blueness, 255 being the most. So all we do is hoik out one of them. I think it's the green for some reason we pick out, I don't know why, and then you can detect the line. So let's have a quick look at that, what we're doing in the code. Bear with. Doesn't want to show up. Right. So we take the picture, and it is a pointer. All right. So the way you deal with images and large data is you deal with pointers. So a picture is a 2D array of U32s in this case, and that's a pointer to it. So with pointers, you have to unbundle them in the pointery bit, which is just saves resources. Means you're not carrying that data around. So here what we do is we just going to go and take a slice. We're going to take a column, and then we're going to break the 32-bit into its component parts, which I'll show in a bit how to do that, but just bear with. So we're taking the green, and then we're doing a line, so it's a column through the graph, through the picture. All right. So let's just see that. So there's us getting our picture, and if we then take our picture, you can see there's our graph. Now if we move the picture, it doesn't have to be column 0 actually, let's move it to sort of column 50. It's 480, 6 by 640, so. Okay, so let's move the graph a bit. So now we've got a skinnier one, and then we take a picture again. You can see it's skinnier and it's moved. So you've got what you've got is movement. You can detect just by this simple method, and you can also detect the width of the graph. So if you've got like a measurement system, you could very easily sort of look at that and go, it's so many millimeters per pixel. This is the edges. A lot of vision is to do with lighting. You know, if you can make it kind of black and whitish. Oh, let's get a couple in. Actually, let's get something a bit more interesting. Let's see what that looks like through us. So you can see that's suitably confusing. But it's quite a nice way of, one, looking at array manipulation, and two, also looking at data manipulation. So let's do the same again, but actually have a look at these numbers, shall we? Let's bring these numbers in. Got them up here. Okay, so we don't need that. Go to that. Go to that. And create another control. We'll call that row. I've not set my default yet, so it's still doing that annoying thing, which I hate, which is that. And then we're going to pull out the unsigned 32. Oh, no, I haven't turned that off either. So the unsigned 32 is going to come up, and these are splitting numbers. So that's taking the unsigned 32 into unsigned 16s and then unsigned 8s. And then we got our colours. And you'll see here now, when we take a picture, you'll get something going on. I don't know what that the third one is. It just seems to sit at 255. I really ought to look it up. I'm sure it means something, but not today. So we take a picture. Thank you very much. I don't know what I've done here actually. Hold off. Done something wrong. That's still those. I thought I dragged it. I didn't. I copied it. Oh well, I'm not going to save it, so let's get rid of those. Boop. And blue and green and red. Right. Okay. So let's try that again. You're not going to see very much because it's white, but bonk. So that's doing stuff. So let's get rid of that. And as luck would have it, that's greenish. And then take a picture. Bonk. You can see the green is the highest. Okay, so very unpure green, but it's still green. Let's see what a fluorescent post-it comes out like. Ooh, look at that under the microscope. How cool. Anyway, and you can see, well, that's very red. And we can turn the brightness down. So it's probably going to be even redder. I know. It's actually quite interesting to see lose all the blue. Anyway, you can see the colour working, and the other uses for this is you can actually detect interesting things, like which colour is doing what. So again, for colour quality type testing, this is also quite useful. So that's that. So there's RGB. Let's stop that. The other trick, if you do want something fairly lightweight that shows you the entire image, is these intensity graphs. They're quite useful little thingies. It'll be interesting to see what the load is on the poor old. But if you just wanted a quick visualization of what you were seeing, ooh, no, that's wrong. Right, that is not right, because that is not a meaningful number. Okay, so what we need to do is essentially take all of these out. So what should we do? Should we do blue? No, we do red. Okay, so we want red. He's our friend. So we're going to take red out. We don't want that. We don't want that. We don't want that. We do want to break it. We now want to go. And we want to go. So I think this makes it grunt a bit. I haven't actually. We'll check the CPU, but the poor little Radxa is going to struggle a bit. Oops. But that's fine. We'll check the heat really. Okay, so using the auto indexing feature of LabVIEW, which always makes this kind of neat, this kind of thing, you can just do that. So plonk him down, make him go up, and then you get a pretty intensity graph. If I can find me. Alright. You might see something. Sometimes I should have done the blue one really, because I've got the blue colour thing on. Boop. Okay, so let's start him off. We take our picture. And there, look, there is something there. Cool. So turn the brightness up. Oh, I'm moving it. Oh dear. See what that does. Ooh, look at that. Okay, it's transposed it. It's pretty quick though. Let's stop that. Have a look at that. Find terminal. I think if we transpose it, we'll get what we're. So, transpose to array. Let's try that. Oh, now it's upside down. She transposed it a couple more times. Just for ugliness' sake. Shuffle. These are actually quite quick, these transposes. I know. Yeah. Okay, let's see what that does. Boop, boop. Perhaps it wasn't upside down. I do enjoy this. Sorry, you have to watch me just play now. Perhaps I was looking at it wrong. Interesting. Oh, it's probably yeah, there's some sort of verticality to it, I think. Anyway, not to worry. Do one more, see what it does. Yeah, so as you can see, we now have images. We now have a way of capturing and taking the images and converting it into an array of numbers. We've got a way of showing it on the screen, and you can use it for various things, and it's quite fast enough. Let's take that picture again. Bonk. I'll start it. You see, it's not really taxing it. Now, we did put a 2D array of numbers here, and I'll tell you what, that really does tax it. I don't know whether there's a old-fashioned bug in 2D arrays in Linux, but that really did worry it. But I mean, oh, yeah, that's too bright. But yeah, it's just it's kind of a nice thing, really. And look, on a $60 piece of hardware, we're doing all sorts of stuff. Now, OpenCV comes with an awful lot of tools. So if we stop this and have a quick look. So I'm not doing this. This is not showcasing OpenCV yet, really, apart from the capture bit. I have to get used to different operating systems. Bog. But you can see here his John's kit, toolkit. So it's got the, and I've not really had a good play with it yet. I've been too busy on other things, but it looks highly useful. You know, this is quite a cool thing. So yeah, and that, you know, adding stuff to it was all very easy. Stopping. You can see it's all starting to capture, and it runs. I don't know how many frames a second, but enough. So let's have a look. How many that is a second, but it's more than 10, isn't it? Feels like more than 10. It feels fairly smooth, a little bit jerky there, but you know, that's quite cool. And that's it.